going to be working on today is our 6-week review. We're going to go over as many questions as we can. Right now, if you look at problem number 1, all right, you don't have to write all this stuff down in your journal, but whatever you feel necessary to write down. You look at this right here. And if we do the vertical line test, through this one, through this one, through this one, through this one, all right? Right now, it says which relation is a function, okay? Which one is definitely not a function? Which one does not pass the vertical line test? A. What about B?
It is a vertical line.
It is a vertical line. So this is kind of confusing right here. Right now, it looks like does C pass it?
Yeah.
Yes. Does D pass it?
Yeah.
Yes. All right. Now, this right here is an absolute value function. This is a parabola. So right now, if somebody, I'm just doing, I would, if I was a student, I'd be like, Mr. Damoud, C and D, both of these relations are functions. So if you see on the test, don't worry, on the test you're not going to have 2 answers, okay? I'm just doing a review right now. So understand C and D are both correct. If we look at number 2, what I would do if I was a student, I would write down, I'm going to highlight what I would write down. This right here, okay, and this right here. That's what I would write down. Before we jump into number 2, just remember, the reason why the circle is not a function, because the vertical line, it hits it at more than one place. It hits it right here and here. Remember, each x can only have one y value. Each x can only have one y value. Each input has one output. Okay? This one, it touches it infinitely number of places. So yeah, that's definitely not a function. Look at number 2. What we're going to do is we're going to take this right here and we're going to plug it right there. All right? So here we go. We're going to say g of 8 plus x equals -2 radical. And what am I going to do with the 8 plus the x? What am I going to do with it? I'm going to square it. So I got to square that. See where it says x squared? So I have to square this. Okay? So what is x plus 8? What is that squared? What does that mean? That means x plus 8 times x plus 8. Now you can do the FOIL method, but what's the fast way? We know we're going to have an x squared. What's 8 plus 8? 16. And what's 8 times 8? 64. So, right here, what does all of this become? When you take 8 plus x, all I did was do what? I used the commutative property of addition and just moved it where the x's were up front. And then squaring it, what did I have to do? I had to do the FOIL method. Well, what's the fast way of doing the FOIL method? Just add those together, put them here, multiply them together, put it there. That's an easy way to do it. That's if and only if the coefficient from the x squared is simply a 1. Remember that. So right now, where does it have this inside of the radical? Which answer? Right there. So that would be your final answer. Your final answer for number 2 would be J. Now I'm going to scroll over here so you can hopefully understand that all of this right here would eventually be right inside of the radical. All right, I'm going to show you how easy it is to do problem number 3. Okay, so right now, if you guys would look at problem number 3, if I were to be a student, I would write this down. I would write f of x equals this, and we're looking for what? We're looking for zeros. Okay, looking for zeros. So instead of f of x, we put y equals x squared plus 4x minus 117. And if I was a student and I had these from graphic calculator and I didn't know how to factor very well, I would just plug it into the graphic calculator and see what the zeros were. Okay? So right now, let's say you're not good at factoring trinomials. What two numbers multiply together to equal 117 and add together to equal 4? Well, fortunately, you look at multiple choice answers. I wonder what 13 times 9 is, just out of curiosity.
Yes, sir.
117. So, how would I take? Which one would have to be positive? Which one would have to be?
B. That'd be 13.
Okay, so we're going to put x plus a what? X plus a 13, and we're going to say x minus a 9. What's 13 minus 9? 4. What's 13 times a negative 9? Negative 117. Now, everybody, we just factor this. So another way of thinking about it is this. Where are my what? Zeros located. So when you make your y equal to a 0, what number would you have to plug in here? And what number would you have to plug in here to make your equation equal to 0? What would be my two answers? Negative 13 and positive 9. So your final answers are negative 13 and a positive 9, which gives me answer choice A. So let's say you're a student that says, you know what? This does not make any sense to me because I do not know how to factor. Well, you still have access to your graphic calculator. You can hit y equals to x squared minus 4. Is it plus 4x or minus 4x? Plus 4x plus 4x minus 117. And if you have to look for roots, if you have A, B, C, D, E answer choices, and you see answers that are negative 13 and 9, then you might want to change your window to what? Instead of negative 16, oh, negative 16 to positive 16, that would work, right? Hit graph. Huh, interesting. Where does it hit? Right there. That's negative 13. Where does it hit? Right here. Do you think you're going to have one that you can type into the graphic calculator, hit graph, and find your zeros? Yes. Okay? Now, on a standardized test, which does not allow you to use a calculator like the SAT or the DSI, what are you going to have to know how to do to prove you're ready for college algebra? You got to know how to do this. If you don't, it's okay. There are developmental courses that you get to take that don't count that as paper. That's okay. Don't be sad now. Just be sad. Alright, let's look at problem number 4. Right now, what are we plugging in, right, everybody? We're plugging in a what? Plugging in a negative 9. Now, where does the negative 9 go? It says, if x is less than 1, use what? Use this equation. If x is greater than or equal to 1, use that. Which one are we going to use? The top or the bottom? If it's a negative 9, we plug in a, we're going to use that. We're going to use this one, right? Because negative 9 is less than 1. So I want you guys to do this. Negative 3 times the absolute value of x plus 5. What number are we going to plug in for x? We're going to plug in a negative 9. We get negative 3 times the absolute value of negative 9 plus a 5. Make sure you don't try to distribute a negative 3 inside of the absolute value. What do you have to do with absolute value? You have to do whatever is inside of the absolute value first. Add those together, you get negative 4. What's the absolute value of a negative 4? Positive 4. What is negative 3 times a positive 4 equal to? Negative 12. Now, I did this by hand, but could you do this in the graphic calculator? Sure. Here's how you do it, right? Go here, hit second quit, type in a negative 3, open up the absolute value, which is alpha window enter, type in a negative 9. What are we going to do? We're going to add a 5 to it. You're going to press enter, and what do you get? Negative 4. All right, moving forward, let's go ahead and take a look at problem number 5. function, symmetry. Odd function. By the way, everybody, when you are dealing with an odd function, that has what's called point symmetry. What does an even function have symmetry with? An even function has symmetry about the y-axis. So any graph that looks like a parabola, right, or a absolute value, and it does what? Basically, that y-axis splits it right here. There's the x-axis. This right here would be an even function. Okay? An odd function is one of those functions that has symmetry through a point. So you can probably see something like a cubic function that goes through like this. And that has point symmetry. So anything about the origin is going to be an odd function. An even function is your y-axis. So it says, if that's an even function, you would say y-axis. If it's an odd function, it's about the origin. What has symmetry with y equals x? What do these talk about if it's symmetrical about y equals x? What does that deal with? That's dealing with functions and their what? Inverses. That's a horrible inverse. Okay? Y equals x is dealing with inverses. Reflections across the x-axis does not have to deal with an even or an odd function. Okay, there's only two types. Odd goes with the origin, even goes with the what? Y-axis. That's what you need to know. All right, number 6 says, if the graph of a function is symmetric with respect to the y-axis, which of these has to be true? So in your calculator, we have what's called y equals x squared. So I'm going to show this point right here and this point right here. Okay? What's this order pair, everybody? That's a -1 and a +1. And what's this one right here? 1 and a 1. What do they share? They share the same y value, but this, if we call this x, this is going to be what? -x. So what happens? If you have, right up here, this point and this point. This is a what? This is a 2 and a 4. What's that? That's a -2 and a 4. Notice what happened to the x values. They're opposite of each other, right? So basically, if you have what's called x, y, if it's symmetrical about the y-axis, what are you going to have? You're going to have -x, but you're going to have the same y value. So when you go back to your problem and look at your answer choices, if you have an x, what does the other one have to be? A -x. That's what that means. Okay? This right here, if it says f of x equals -f of x, you know what that does? That actually reflects not across the y, that reflects across the x. So G, that answer, what I would probably do if I were you, I would say, okay, f reflects across the y. And G reflects across x. By the way, if we're doing a review, it could be one of those two answers, right? So you need to know the difference between those two answers. So in this particular case, the answer is F. But if I change this right here and said, you know what, I'm going to change that from the y-axis to the x-axis. If I just change that one little tiny phrase right there, then the answer would be G. Okay? All right, moving on. Ooh. Which function has infinite discontinuity? All right, infinite discontinuity. So, right now, I realize that right now we don't We can type in all of these, okay? But I'm going to let you know what the answer is.
Yeah.
All right? And we're gonna type this in and let you know what infinite discontinuity looks like, okay? So there's three different types of discontinuity. There's infinite, there's jump, and then there's what's called removable. This is removable, everybody. This answer right here is removable discontinuity. All right? If x is, it's 2. If it's this, it's greater than 0. It's this. This right here, everybody, this would be jump discontinuity. That's what A would be. That would be jump. If we graphed it out, that would be jump. And then D right here, this is just continuous. There's no discontinuity. This is continuous. So if you wrote down these three answers, this would be removable. And I'll explain why it's removable. This is x squared minus 49 over x minus 7. Just so you know, this factors to x plus 7 and x minus 7. And guess what happens to these x minus 7s? They cancel out. Whenever they cancel out, that's what's called removable discontinuity. All right? So we're going to go ahead. We're just going to go ahead and graph C so you guys can see it. Y equals alpha, y equals enter. It's 1 over, what is it? 2, is it 2x minus 9? 2x minus 9. I better go delete this. Delete that. Okay. If I hit graph, does everybody see right here? Whenever you have an asymptote right there, what does that provide? That provides what's called infinite discontinuity. Okay? So there's your example of infinite discontinuity. We have, what were the other two questions? The other two were what? Y equals 2, right? So I'm going to put 2. I'm going to put divided by, open parentheses, if x is what? Less than 0. So x is less than 0. Second math, 5 to the 0. Then over here it says y is 3 divided by, if x is greater than or equal to 0. Yeah, greater than or equal to 0. X. Second math, 4, 0. Close it. Hit graph. Let's take a look at those. Does everybody see how those are jump discontinuity? All right. It's not continuous, because if I were to trace it, what would I have to do? I would have to go here and have to do what? I'd have to jump up. So that's called jump discontinuity. All right? The next one that you saw that I told you was removable was this one. Alpha, y equals enter. I said x squared minus 49, and then the denominator was what? An x minus 7. And you're gonna see a line. I'm just letting you know, you're gonna see a line. You see that line right there? That looks continuous, doesn't it? But you know where it's not continuous? It's not continuous where x is equal to a 7. Check your table. Right here. What does it say for 7? It says what? Error. Okay? So right here, that's your example of removable. If I could just remove that one little tiny point, it would be continuous. That's why they call it removable discontinuity. All right? Because if I hit zoom, say zoom standard, it looks like it what? It looks like it's continuous, but there actually is one point where it is not. So, in review, this answer is jump. This answer is removable. This answer is the answer. That's the answer for infinite. And this answer is continuous. So you could have a question that asks you, which one has what? Jump. Which one has removable? Which one's continuous? All right? So depending on what that says, you got to know the difference. Over here, you got to take care of. Moving on. Right now, it says, for g of x equals 5x minus 1 over x plus 3. What expression for a makes this correct. So here we go. We're going to say the limit, everybody, of g of x equals a as x approaches what? As x approaches what? Infinity. So right now, if x is approaching infinity, we are actually looking at what's called the right end behavior. Remember we talked about right end behavior and left end behavior. So what we're going to do is look at this graph right here. All right, look at this graph, and we're going to look at the right end behavior. So type that into your graphing calculator. Here we go. Y equals alpha, y equals n. Type in 5x minus 1. 5x minus 1. Go down here, do what? X plus 3. Let's hit the graph button. Take a look at it. Ah, okay. Let's look at this right here. So we have this graph, and right now, as x is going this direction, as x is approaching what? Infinity, what's happening to all of my y values? Are they increasing or are they decreasing? They're increasing. Where are the y values, like, even though they're not going up very far, where are they heading towards? They're heading towards positive infinity. So if you were to go over here and say, which would be correct? Oh, it says positive infinity, doesn't it? Interesting. There's no positive infinity, is there? Interesting. So what we're going to do is just take a look at it a little bit closer. If they're not reaching positive infinity, they're definitely not reaching negative infinity, right? Correct. It's not going towards 0. It's definitely not going towards negative 1. So the answer must be 5. But wait, why is the answer 5? I'll explain. Do you guys see right here how this is a power of 1 and this is a power of 1? That means there's actually a horizontal asymptote at y equals 5. Whoa. So right now, even though you didn't recognize that this was the answer, you can still figure it out by, look, go to y equals, I'm going to type in right here, 5. I'm also going to hit graph so you guys can see how this looks like it's getting what? It's increasing, but you know where the asymptote is right there? It's right there at y equals 5. So watch this, second window. I'm going to start the table, I'm going to put it at 300. We'll do 300. Let's check it. Second. By the way, if you did 1499 divided by 303, you know what number you get really, really, really close to? 5.
5.
94 divided by 19, you know what that's really close to? 5. Okay? So, no matter where you are, what's the limit? What's the limit right here? The limit is 5. That's why the answer is J. So what you're going to do is you're going to type it in and you're going to evaluate it. Okay? This had a horizontal asymptote. It also had a vertical asymptote. The vertical asymptote would be at negative 3. So if you look back at the graph right here, you would also see a vertical asymptote right here where x was a negative 3 as well as where y was 1, 2, 3, 4, 5. So it had a horizontal asymptote and a vertical asymptote. One of them was at x equals negative 3. This horizontal was at y equals 1. That's your answer. All right. Number 9. By the way, number 9, I want you guys to think of a sheet of cardboard, okay? We're going to call this sheet of cardboard right here. You don't have to write all the words down, all right? But you write this down. Put it 22 inches right here to 15 inches right here. And it says he's going to cut out corners of equal size. Now, what does that mean if you're going to be cutting out corners of equal size? That means you're going to cut out a corner here. You're going to cut out a I'll just draw it. We're going to cut out a corner here. We're going to cut out a corner here, and here, and here. We're going to cut out 4 corners. By the way, I'm going to cut out equal lengths. I'm going to call these all these x's. Okay? So I'm going to cut all of these out. So right now, I want you guys to think of what the original length was, and now ask yourself, if the volume of the box is equal to the length times the width times the height, what would this length be now? If it was 22 and I took away an x and an x, that's going to be 22 minus x. And if I took away an x here and an x here, what's going to be the width of the box? That's going to be, oh wait, messed up. Not 15 minus x, minus 2 x's. 22 minus 2 x's, and 15 minus 2 x's. So what's the length of the box? The length is 22 minus 2x. What's the width of the box? 15 minus 2x. Now if I created this box, all right, and I'll just draw this box right now. So we have a box, looks like this. All right, and I say the length of the box is 22 minus 2 x's, and the width of the box is, here's the width, 15 minus 2 x's. What would the height of the box be if you cut out the same distance no matter what? The height is just going to be what? X length of height. And then you can fold the box together and make a cardboard box. So the height of everybody is x. So if you guys would please in your calculator, just type this right here where it says y equals. Where it says y equals, because y equals the volume. Okay? Y equals the volume. I want you guys to type in. Now on your test, your question will already have the equation. I just want to show you how to build an equation. Here we go. So you're going to write 22 minus 2x. Then you're going to say 15 minus, minus 2x. And then over here, the height was x. And what I want you guys to do is just check your table. Check your table here. All right? Oh, you might want to start your window. Sorry, not at 300. Start it at 0. So what does 0 represent? 0 represents if you don't cut anything, right? What's your volume if you don't cut anything? 0, because it's a flat piece of cardboard. If you made it 1, if you cut out a length of 1, what's your volume going to be? 260. If you cut out a 2, what's your volume? If you cut out 3, what's your volume? Cut out 4, what happens to your volume? It starts going what? So eventually, guess what? You got to stop cutting because otherwise. So basically, what are you allowed to cut? You're basically allowed to cut from what? From 1 all the way to what? 7. And what's the maximum volume you could have? Yeah. Now, so the maximum volume is C. By the way, on your problem that you have to evaluate, you don't have to build the equation. All the equations are going to be there for you. This right here is a college algebra problem. When I was tutoring kids in college algebra, I saw this type of problem many times where you had to set it up and figure out the maximum volume that it could be. By the way, why would somebody need to know how to do this? If you're shipping things and you wanted to create something with the least amount of material and have the most volume with the least amount of material, this is how you would do it. You would figure out, oh, this is what we need to cut it to so we have the maximum volume out of this box.
What are the college schools